Alright, so in this problem, I'm going to be proving that 3 plus 3 is equal to 5. So, to prove this, I'm going to first start with the statement 0 is equal to 0, which is obviously true because any number is equal to itself. Now, what I'm going to do is for my left-hand side here, my left-hand side 0, I'm going to rewrite this as 9 minus 9, which is obviously true. Any number minus itself is 0. However, for now, for my right-hand side, I'm not going to do the same thing. I'm going to instead write this as 15 minus 15. So this is obviously legal. 9 minus 9 is 0. 15 minus 15 is 0. So there are no issues there. Now, for my left-hand side, 9, this is the same thing as 3 squared. So I'm going to write this as 3 squared minus 3 squared. And for my right-hand side, 15, this is equal to 5 times 3. So I'm going to write this as 5 times 3 minus 5 times 3. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I have 3 squared minus 3 squared, and a in this case is 3, and b is the same thing as well, 3. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 5 times 3. Now, if I have something in the form a times b minus a times b, this is the same thing as a times b minus b. So I have 5 times 3 minus 5 times 3, and if I factor out 5, I get 5 times 3 minus 3. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 3. Now, if I divide both sides by 3 minus 3, these two cancel out, and I get 3 plus 3 is equal to 5, or 6 is equal to 5. And this is obviously wrong. Where the mistake is when I divided 3 minus 3 on both sides, because 3 minus 3 is 0. So this is technically dividing 0 by 0, which is not 1, but it has no defined value. So that's where this proof went wrong, and this is wrong. Alright, so in this problem, I have m to the power of 9 is equal to 13 to the power of n. So now the first thing I'm going to do is I'm going to take the natural log on both sides. So now I have ln m to the power of 9 is equal to ln 13 to the power of n. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front. So this is going to equal b times ln a. So in this case, I have 9 times ln m is equal to m times ln 13. Now, if I divide both sides by 9m, these two cancel out, and these two cancel out. So now I have ln m over 9 is equal to ln 13 over 9. Now, I'm going to take 5 something in the form e to the power of ln x. This is equal to x. So now I'm going to change this to this is actually not 9, this is m. This is supposed to be m. So now I'm going to take e to the power of ln m on both sides. Now m here, this is the same thing as e to the power of ln m. because remember, these two cancel out. So now I have this is equal to ln 13 over 9. And now this is the same thing as ln m times 1 over e to the power of ln m, which is equal to ln 13 over 9, which is the same thing as ln m times e to the power of negative ln m, which is equal to ln 13 over 9. Now, if I take the W-Lambert function of something in the form a times e to the power of a, this is equal to a. So, what I'm going to do is I'm going to multiply both sides by -1 first, because we want a and a over here to be the same. Right now, this is negative ln m, and this is positive ln m. So if I multiply both sides by -1, I get negative ln m times e to the power of negative ln m is equal to negative ln 13 over 9. Now, if I take the W-Lambert function on both sides, I get negative ln m is equal to w of negative ln 13 over 9. And now, I'm going to take e to the power of both sides. So now I have e to the power of negative ln m is equal to w of negative ln 13 over 9. Now I can move this negative to the front. So now I have e to the power of ln m to the power of -1 is equal to w of negative ln 13 over 9. And now these two cancel out. So now I have 1 over m is equal to w of negative ln 13 over 9, meaning m is equal to 1 over w of negative ln 13 over 9. So this is my answer. All right, so I have x to the power of x is equal to x to the power of 2. So to solve this, I'm going to first divide both sides by x to the power of 2. So then these two cancel out, and now I have x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, I can write that as x to the power of x minus 2. And this is equal to 1. Now, if I take the natural log, or ln, on both sides, I have ln x to the power of x minus 2 is equal to ln 1. And if you guys already know ln 1, that's equal to 0. So now I have ln x to the power of x minus 2 is equal to 0. So now this gives me, before all of that, now I can actually move this to the front, because if I have something in the form ln a to the power of b, I can move b to the front. So this is going to equal b times ln a. So if I move x minus 2 to the front, I get x minus 2 times ln x is equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0, and I have ln x is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2. And for ln x equals 0, I'm going to take e to the power of both sides. So now I have e to the power of ln x is equal to e to the power of 0. E to the power of ln x is simply x, and e to the power of 0 is 1. So my two solutions are 2 and 1.